This is going to be our multi-part storm full maintenance guide video. We're going to go as in-depth as we can, film this in sections, and talk about everything that we've ever had go wrong, and answer some questions, debunk some myths, that kind of stuff. So this is a storm in the lavender pink variety with our prints. It works great. Did some test firing around the shop, but there's a handful of things that can go wrong, and we're going to emulate them. If you have any questions after watching this video, feel free to reach out. Also, if you would like to do like a Q&A or a live stream type format, let us know, and we can set that up as well, where we can help you debug your storm over a video feed. We've done that before, and I think it's about time we do that again, because the Storm is an amazing blaster. I personally like it a lot. I mostly just run semi-auto, but those full auto bursts are fun to scare people. But with the right B-car and the darts barrel, it is very accurate, and it hits over 300 FPS, semi-auto. It's go-to high power, no need for priming a spring, faster follow-up shots. And at New Jersey's BPOC event, one of the highest marksmanship accuracy scores of that event was actually with a Storm, with this very similar setup without any iron sights, just kind of plinking up the target. He had a really high score, and so the Storm is definitely great. But again, like any blaster, it needs maintenance and upkeep to continue to perform well. Specifically, the Storm has some electronic and mechanical things that can go wrong. A Springer, get dirt in the O-rings or whatever, will have that fail on you and things loosen up. The Storm, I haven't really had to worry about the O-rings or lube or any other maintenance other than things going wrong that I've done, or of course the normal blaster jam, misfeed, bad dart, those kinds of things. If you get a bad enough jam, you keep firing, of course you could burn out a fuse or something. I've never had a motor die. I've never had a motor brake board die. After I know how it works and I've gotten familiar with the platform, I haven't had any problems. New out of the box, you might not know how to handle it, and so hopefully this guide will help you if you've just got a Storm or thinking about getting a Storm, to give you the information so that way you don't have to learn by trial and error, which is how I learned. So without further ado, we're going to go into the common issues with the Storm. The Storm is serviced almost entirely by hex keys in a variety of sizes, so you will need a pretty good size full set to do a full service job. But I'm just going to start by taking off this B car, because assuming you have a problem with it, that's something easy to take off. You know, you could get a dart. I sometimes get a dart folded in the barrel if it's like a bad dart and it gets stuck in the B car. I haven't had that in a long time, but that could happen. Boom, so B car issues, accuracy issues, that's all barrel front end dart type stuff. And you're missing an O-ring or something like that, the pusher O-ring. Let me start this cycling here, because I don't need this battery door for anything, and grab a battery as well. I'm just going to use a 4S LiPo, because that is my preferred LiPo for snappier, faster follow-up shots. You can also use 3S LiPo without any problems. In fact, because of the slower cycling, you might get some better consistency out of a 3S LiPo. If you're doing full auto and that cycling speed is too fast for, say, your mags to keep up, or if you're running darts that might not be very new, I would recommend perhaps downgrading to a 3S LiPo. Or if you have a 3S already, you can use it. So here's a 4S LiPo. As we mentioned before, what it should work is you plug in a LiPo, and the charging carrier, that little tan piece, should slide back, lock into place. The bolt should then cycle once, load a dart, ready to go. That is if it's off of safe. So plug in your battery, put it into semi-auto mode, which is one tick forward, and you should see the priming ball thing move back, and then the bolt open and close. That worked. So on a 4S, it moved back pretty fast. On a 3S, it'll move back a little slower. But then reset will be the same speed, and then you can then test your air seal or make sure it functions without dry firing by pulling the trigger. And if you plug the barrel all the way and fire, and if you fire fast, depending on your air seal, if you have too good of an air seal, then you'll create a buffer in front of the plunger, and so if you cycle it again before the plunger has a chance to fully reconnect to the bolt, then the plunger will cycle before grabbing the bolt, causing it not to feed. So if you get a shot every other time you pull the trigger on semi-auto, that is usually the case. So if I pull the trigger twice fast, I can't seem to create that issue on this one right now. I think that is because my O-ring is dry and my barrel is slid forward. But if you have the issue of the bolt not resetting when you pull the trigger, oh, this is because I have upgrade spring as well. But if you then let go of the trigger, you should cycle. So it cycles when you let go of the trigger. So you fire, you know, let the whole system fire, reset, and then you cycle again. And if it doesn't recycle when you let go of the trigger, then that is usually an issue with the plunger interface O-ring not reattaching to the pusher. So I said too good of an air seal will cause it not to cycle, but that's mostly because you're then recycling before the plunger can get full impact and reattach. So another cause of that could be a weak spring. So if you're getting firing every other shot, then check for maybe your weak spring, and so your spring at fully relaxed is not able to compress the plunger into that interface O-ring. And again, we'll show you this again later, but this is the explanation, and then I'm going to take it apart and explain it again. But it's not interfacing. So it's not interfacing, which could be caused by the spring being too weak to seal it, or we're not allowing the plunger to fully reset before cycling again, causing it to kind of double feed without actually moving the bolt. So that's a common issue. A lot of jams, we talked about the accuracy, a lot of jams can occur with the magazine. This is a XYL unicorn mag. They have a pretty good spring follower that I can keep up on that full auto. If you're getting a lot of jams or it's squishing your darts or not cycling right because of the feed, meaning if the bolt is moving but you're still having feeding problems, I would then check your magazine. If you have regular 15 round talons that are worn out or 18 round curved talons with the weaker spring, it might not be advancing the darts fast enough, or even Tachi or Koda mags on the last couple of darts. If the spring is not strong enough, then it might not advance the dart fast or as fast as the bolt retracts and then moves forward, which is why 3S will help with your reliability because it'll move back slower, but the reset of the bolt will still be the same speed. So the dart still only has that distance when it moves back and then moves up and then stops and resets to chamber the dart. So the mag has to be able to keep up. So if you need to, you can double spring your mags, get stronger springs in your mags, like a thicker wire in your mag springs, or get these XYL mags, or just don't overfill your mags, especially you should never be overfilling your mags anyway. Your feeding issues will usually be caused by the dart and the mag, and usually not anything else I've noticed. They do say that moving the barrel out a little bit can help it chamber or feed more correctly, but that's mostly because of, I believe, one, the friction of the dart being pushed by the bolt in the barrel, causing it not to fully reset, or because the air seal is too good, causing it not to reset if you cycle too fast. But anyway, check that first. Check the mag feeding. LiPo was charged. If your LiPo was dead, a lower voltage battery. Now, I'm not an electrician, so this might be wrong theoretically, but what I've noticed is as your voltage drops in your battery, the amperage will increase to compensate, resulting in a higher heat output. So if you have a dead battery, it might not cycle correctly because the fuse might be blowing out. So if you plug in a battery and it's not cycling all the way, a lot of times with a dead battery, it'll cycle part way, but because the resistance at the end is strongest, it'll cycle part way and then stop about 2/3. So the first thing I would do if it's failing to cycle altogether, this priming block is not moving all the way back. I'm just going to deprime it here and put it in the safe. If this is not moving all the way back, then the first thing I would check usually is the battery, because if you don't have enough power, you're not going to be able to cycle. And that's an easy thing to check for, because you should charge your battery before you use it anyway. But if your battery is dying, definitely check that. If it's runaway, the next problem that we see often people email about is it's stuck in full auto and won't stop. This one I can emulate because there's a couple of things that control the cycling. Despite myths, it's not the cycle control board. That simply is a motor brake board which controls the stopping of the motor, so it makes it stop fast. And usually when that goes out, then it just won't have any power at all. I guess, yes, technically, if something goes out on that board, you could get stuck in full auto, but I've never had that be the case, not even once. I've never had a board go out on me personally. So if you're doing things as intended, you shouldn't have problems. But anyway, so to explain the cycle control, this knob here controls when the blaster cycles. So the priming will come back until the plunger hits the position of the switch, and then it stops priming, indicating, hey, you're at the end of your travel, so stop and then wait for the trigger response. And so in full auto, instead of waiting for the trigger response, well, it's going to wait for the trigger response, but it's going to wait for it to be held down, and then keep cycling until it's released. On semi-auto, it'll simply say, okay, cycle once, by having the switch be kind of the cutoff. So when the plunger reaches the switch a second time, it will stop. So that is why it cycles when you let go, because when you let go of the trigger, that's then cutting off the connection to the trigger, so the machine then thinks, okay, I'm no longer firing, so then I can cycle. Because with the trigger pulled down, it'll say, I've fired, and so it'll move back, or it'll move the motor when you pull the trigger to disengage from the switch. Then when the plunger moves forward, the motor won't move back again until the switch is unpressed and this back switch is unpressed. But when this switch is pressed, it'll then stop moving back. So it's kind of like this acts as your stop for the semi-auto function. So that'll make more sense as I work through it here. So this will work as I put it in semi-auto, and then this priming block will just move back until it hits the switch. And because of the physical dimension of the bolt restraint, then when it moves back, it'll also release the bolt. So you'll see that when it moves back, it hits the position there, and when it hits the position there, the bolt releases. It's a physical stop for the bolt. This is electrical with the switches. So now that it's stopped, we can see that when I fire it, it'll say, okay, I'm in semi-auto, so when I detect the trigger being pressed and I detect this switch being hit by the plunger, when both switches are pressed, it'll then cycle, which means it'll move past the lock or the catch, release the plunger, but then it won't cycle until it then detects the next series in the logic, so it'll fire. But now it senses, oh, I've got the trigger pressed and this switch unpressed, but I'm not going to cycle until both are unpressed. And I'm going to stop cycling when the back is pressed, or the front is pressed, technically. So I could stop at half stroke. Let's let it move a little bit, and then I can kind of jump my finger, and that's how you can access, maintenance, and lube your pusher O-ring. But because it says if either switch is pressed, I'm going to stop cycling, then that's how it works on semi-auto, where the motor is stopped. The motor isn't actually pushing or pulling right now, it's just stopped. So it's not putting additional strain on the motor or the battery where it's not drawing continuous current to hold back a spring or something. And then when it detects that I'm off this switch, it'll move back until this switch is pressed, and that's how the semi-auto works. The full auto is exactly the same, but it only cycles when the trigger is unpressed. So the limit switch in the back for full auto doesn't actually matter. So it doesn't use this switch on full auto. So if you are stuck in full auto only, when you plug in your battery, put it in the safe, and it just goes, that is usually because a fault of this cycle control switch, because this control switch controls the cycling in full auto, or I should say controls the cycling in semi-auto, and so in full auto, it kind of ignores this altogether. In full auto, it only relies on, well, the trigger to say go, and then once you let go of the trigger entirely, it'll stop again at the switch. So if it's only firing and not stopping, it's because of this switch here, and the trigger is pressed. Hopefully that makes sense. But we can also emulate that by depriming, going to safe. If we pull this switch to the front, we talked about that mechanical bolt. So when it's too far forward, the cam will go back and it won't go far enough to release the bolt because it hasn't let the mechanical limit. So you put it into semi. See? It moved back, stopped here, and the bolt stopped because it wasn't yet at its limit, because moving back further is when the bolt will then reset. So that is your minimum distance for your cycle control switch to be set in order for it to cycle, is whatever position or length that is, which can vary depending on the tolerances of the hardware and prints, which is why it's adjustable. So in order to get the minimum cycling required for semi-auto, we will then move it back until the bolt resets. And as I move back and disengage the switch from the plunger, it'll continue to move back and follow it till I reach that point. There you go. Right there. Somewhere around there. And that is where your blaster should be set when we ship it to you. Oh. See, it's like right on that middle spot, so it doesn't quite cycle all the way. So if I moved it back a hair, it would cycle better. So it should be about the third or second to last notch, and you can keep moving it back, just wherever you need to cycle it for, or whatever. However you need to get it to cycle, it can loosen up and move during shipping. But with that same logic, if I move the switch so far back the plunger never contacts it, it'll be stuck in full auto only. And you'll know that by when I put it into safe and I slide the switch too far back, put it into semi, move back a little more, slide that switch all the way back, tighten that back down, put it into semi, pull the trigger. So stuck in full auto, because when I pull the trigger, it's detecting that this is pulled and this is never pulled, which assumes that it is in full auto mode or stuck. The plunger or the motor will keep cycling until it detects this switch and then stop. And so when I let go of the trigger, it'll just keep going. So if I pull the trigger, won't do anything, because again, it's assuming, oh, you fired, I'm not gonna cycle yet till you let go of the trigger, and then you get full auto, then you can stop it by pulling the trigger. So it'll stop when it detects a switch, and so either switch works, trigger switch, or the cycle control switch, so move that forward. Now we got normal full, or normal semi-auto. Now full auto we just saw, but again, if I put it in full auto, I pull the trigger, it'll just keep cycling, and it'll only care when the switch is detected or pressed when the trigger is released. So that could work. If your switch ever goes out, you can still run full auto by using this as your trigger switch, by just cycling that. So you could basically hold the trigger down and then use this as your actual trigger. I've done that in the game once. Okay, so we kind of explained how it works. That should basically troubleshoot all your problems with what you commonly have. Now to actually get into it and I diagnose if you do have a problem, usually it's because you take it apart, you break something, or you let somebody else use it, you get a really bad jam, like you try to move this switch with the plunger back, and so the arm of the switch ends up catching on the plunger and breaking or something like that. But to show you that, we're going to take out the stock. That's generally how you're going to do basically almost anything you do on this blaster, is remove the stock first. Slide that out carefully. I'm going to drop that stock screw out. Then I can slide this out. Be careful with the wires. Those pretty small connections. They're a JST SYP. No, not the SYP. They're a small JST. Can't remember the actual abbreviation, but they can be fragile. But now we have that off, we can check if it was stuck in full auto and then moving the switch didn't fix it or do anything. What I would then check is the actual cycle control switch. If I pull this down a little bit, but not so much, I break this print, you can see that there's an arm on that lever. Or actually, there's a lever on that switch, there's an arm on it. And if you get a really bad jam or just over time, I don't think I've ever seen one break without some sort of misuse. But the switch isn't gonna work if you don't have that lever. So then you can unsolder that and replace it with a new one. I'll show you that here in a second. The other thing that can happen is if you're running mag dumping on full auto, or you get a bad jam and the motor is drawing current, meaning it's trying to pull back, but something is stopping it, not the trigger stopping it, and not the cycle control switch stopping it, because that would mean that it stops power altogether. So if you ever get a jam, you cut the power, which is turn it off, or if you're in a semi-auto, it would work to hold the trigger down, because it also cuts power as long as this switch is pressed. So if you ever get a jam, just cut the power, put it into safe mode, unless you really remember what's going on. And that can be muscle memory as you use the storm enough. But once you cut the power, you won't have any problems with drawing too much heat or current. But if you get a bad jam, I've actually had some people get debris, sticks and twigs in there, or it's cycling in full auto and it won't stop, or the screws are the wrong length, there is too much friction, so the motor is trying to pull back, but it physically can't generate enough torque. It'll then generate a lot of heat, resulting in this fuse blowing. It's just this little fuse there, and to replace it, I just grabbed some needle nose pliers. I've got these big old wire stripper needle nose, but anything will work as long as you can reach it. These ones are too big. Wait, nope, I got it. You just tug on that ceramic. If it is dead, try not to break the white ceramic, because it's harder to get out. But if you can grab the white ceramic and pull up, you can get it out. Let me grab a better tool for this. Don't squeeze the fuse too hard. You want to just squeeze it enough to get a grip and pull up. And I'm holding the board down as I pull up. There you go, pops right out. If you squeeze too hard and break it off, you can then use like a small flathead screwdriver and pry it up, but you also risk breaking your fuse housing as well, since it is kind of fragile. So just be very careful when you take out the fuse and put it back in. Now that fuse will blow again if you're trying to draw too much current or too much heat. So as the components heat up, there will be more resistance in the electronics, resulting in greater amperage being drawn, resulting in the fuse blowing. So if you're running full auto, like mag dumping consecutively, it can create a lot of heat in the back of the motor that you can actually feel. If you put your hand on the stock, you can kind of feel it getting warm, and that means your fuse is more likely to blow. In addition, if you are trying to make it cycle, but it can't move back far enough because the screws are too long or something, or you reinstall the spring and something got stuck in there, or there's something stuck on the ball, or it's dry, then that can cause the motor to pull back and have too much resistance and then stop. So if it stops about 1/3 of the way or 2/3 of the way there, and it's not the cycle control switch, and it comes back and then stops about part way, then that's usually the fuse blew because the motor just didn't have enough torque to come back. So that can happen. Basically, if any of the moving parts can't move when they're supposed to, you're gonna draw too much power and the fuse is gonna blow. And if you bypass the fuse and continue to run power, you will then at some point blow your motor. I have not had that happen yet. I have had my storm start to smell like something was beginning to burn, but it still worked after that, so it might have a little less response or torque. I haven't had that happen though, but the fuse, that's how you replace the fuse. Another issue we've seen is this board can actually jump loose. If it's too loose on the motor tabs, then over vibration, over time, it can actually work its way and then come off. And so some people plug in the battery is charged, and they pull the trigger, nothing happens. Or sometimes it kind of intermittently happens, like there's a loose connection. Well, sometimes that's the board connecting and disconnecting because it's loose. So you can put it on there, and then I like to shim the stock with a dart. I just put something foam or a cotton ball back there, so that way it puts some pressure on here. You want to use something though that ideally doesn't cover up too much of it, like something that doesn't breathe, because this MOSFETs will heat up and you want to give the motor room to breathe, which is why there's holes in there. So if you don't want to do that, you can also check the spade connectors. Over time, these might come loose, so you can grab a pair of pliers and kind of tighten them down a little bit, and then that gives them a tighter fit on the tabs. But if you're getting intermittent response from it, meaning like it'll fire, then not fire, and then like maybe you're running around or you're shaking it and it sometimes fires and doesn't fire, that's usually the cause, is a loose connection from the motor brake board. It could also be a loose connection from this guy or the battery. but usually more often than not, it is the motor brake board itself. So again, really annoying problem with a really simple fix. If you don't know what you're doing, it can be frustrating, but just check connection. You know, if it's intermittent, check connection. Other than prints breaking, if you have to swap the prints, that's about all the maintenance I can think of. Of course, if you're not getting quite enough power, you could always lube it as well, and I'll show you that in a second. Also, the spring being too short, like I said, not having enough pre-compression at its fully extended length can cause it not to cycle, and cause you, even if it does cycle, if you leave the spring primed for a while, you might lose some power. So to swap the spring, take the stock off, I like to disconnect this motor brake board so I don't accidentally damage the wires. And that's just this little tiny connector I pull up with my fingernails. You could also use a pair of pliers. Slide the board off of the terminals. So then to take the spring out, we are then going to remove this side panel and this nameplate. But I set it up so you can remove the charging block cover without removing the nameplate. There we go. This is a 3mm hex key. Most of the screws are going to be a 2.5mm drive. Make sure it's deprimed and everything first though. To deprime it, you will probably have to put it in the battery because the way it cycles is electronically. Once it is primed, the battery then makes it move back a little more to fire it. So even to deprime, you need the battery in it. Don't forget that. If you take your battery out and you leave it primed, you will damage your spring as it sits compressed. So decompress your spring when you're done using it. And we'll take this nameplate off, this dust cover, just like that. Make sure you also don't lose your priming ball. Could be Delrin, could be brass. Either one works just fine. They recommend the Delrin one because as it gets dry, it's slipperier than brass. If you use a metal ball, which still works, if it dries out though, then you're gonna have metal on metal rubbing, and that's usually not ideal. But now we have that cover off, we can then remove the motor and then access our spring. So I'm gonna take my 2.5, I'm gonna unscrew each of these 8 motor mount screws. Want to be careful about this cycle control arm. Don't bend the print so much that it breaks, but you do want to make sure that arm is not in the way when you reinstall anything going this way. When I put the plunger back in, it could snag that arm and break it. That has happened to many people because they don't realize that they have to watch out for things when they take things apart. But yeah, just don't shove it in. Be very intentional and aware of what is here and what you're doing. So I'm gonna take all the screws out but one. So now all of the force is on that one screw. Now because there is pre-compression in that spring, you want to keep your motor from shooting across the room and landing on those motor tabs. If those tabs get squished, you can pull the tabs out to make them longer again. That has happened to me when I dropped my motor on the ground. So I'm going to loosen this while supporting the back of the motor, just so that way it doesn't shoot across the table. So it just shot out, half an inch, not too bad. But then I can slide this out. And then you can see if these tabs hit the ground, they'll get crushed in, and then you can pull them out with pliers, but don't do that. And then you can see all of the set screws holding the cam together and this big orange bearing in there. And so you can make sure that these stay tight. That's what's holding on this entire camshaft onto the motor. And then this motor is in this housing. So that's how that works. When you reinstall this, again, make sure you don't break the lever off the switch. I'll set that aside. To switch out the spring, it's just right there. There's the spring. The spring does rest on a spring rest in the plunger, so you have to make sure that when you drop the spring in, it goes on that spring rest before you put this plunger or the cam back on. If it is not, then you will not be able to have the plunger fully primed, and you'll end up with the motor trying to pull back, but it can't because the spring isn't rested properly, causing it to kind of torque and then burn out your fuse, like we mentioned a couple times. Now, to then service the O-rings and whatnot, it is a little more complicated because you have to go through the front, which is not that bad. There's a lot less moving parts. I'm going to not do that right now, but I am going to show you the plunger to kind of troubleshoot that with at least lubricating the plunger. So to get that out, I would just pull this back, but be careful, there is a spring on the bolt causing it to reset. So if I just pull it, yank back, I can feel when it stops, and then it'll disengage like that. Be careful, don't smash your finger. But you also heard that when I pulled it back, and you can see that I lost this washer here that was inside of the plunger. So they put this washer in the plunger for the thrust bearing. So I'm gonna slide this out. Then you can see that inside here is that spring post with the thrust bearing. That thrust bearing is sandwiched between two washers, so you can just keep that on there. And then this is your plunger. It's a Delrin solid piece plunger with an aluminum insert with an O-ring. So that O-ring you can lube if it gets dry like any Springer. The interface we mentioned before, if you're cycling every other shot and you're pretty certain it's not your spring, it's this O-ring on the inside here that can wear out. It's just an O-ring that then interfaces with the back of the bolt. And so if you're cycling thousands of times, like my original Storm, I dry fired thousands of times because it sounded really cool to show people how fast it cycled. It wears out really quickly, especially if it gets dirty. So you can replace that. Now, you can also replace the spring at this point. And then this just slides back in. But again, you want to make sure that when you slide it in, you bend the cycle control lever out of the way so it's beneath the body to then slide this in. Don't let go until the plunger is all the way past that switch. You also want to make sure that this circle is facing you. This circle is where the priming ball goes into. There's only one on either side, not all four sides, so you want to make sure that lines up. When you press it forward, you can hear it re-engage with the bolt. Click, we're good to go. Then replace the spring. Again, I'm going to drop the spring in onto that spring rest, but not hit the lever. I'm going to drop it in there, shake it around. It is fully seated on that spring rest. Then I'm going to do the same with my motor shaft thing, making sure I don't hit the catch lever. Boom, there it is. Then the last thing is when I reinstall this, I want to make sure that my polarity is lined up. So I'm just going to make sure that this purple mark here and the positive is facing me like that. Okay, and then we'll just compress that down. And I like to use my hex key or a hex key as a placeholder because I'm going to compress that spring. And this is where you're compressing the spring with your fingers, and if you have dainty fingers, you might want to use something else to push on the back of the motor without damaging the tabs. So maybe use a barrel or use a buddy to push it in for you. And then when you see these holes line up, insert your stop. And then we can replace these are 6mm M4 screws. We'll tighten one all the way down, just finger tight, and then I'm going to do this. And when I tighten these, I use a medium torque setting, or I don't use the long side of the handle so I don't end up stripping the aluminum, because it is just steel screws going to aluminum. Oh, and also a common thing of maintenance to do. Common maintenance would be to thread lock these screws, use blue thread lock or something that'll keep them from vibrating loose over time, because that can happen because it is just really short screws being threaded into metal on metal, so it'll vibrate a lot. So any of these screws that are metal on metal connections, you can use thread lock to help prevent it from loosening over time. We also have some written guides as well that can help you if you're more of a step-by-step guy than a follow-the-video guy. The only other thing I have noticed is on a pre-assembled version we got, the dart gate wasn't installed all the way forward, so the darts themselves were getting caught, or the magazine wouldn't be able to insert all the way. You see where the magazine is kind of just touching that black piece in there. So if that dart gate is installed too far back, your magazine won't be able to go all the way in, but that's a pretty obvious problem, I believe, if you see that happen to you. And then, of course, we have troubleshooting, such as if you do break that lever off and need to resolder it, that's just resoldering the connections. I would recommend soldering them one at a time so you don't accidentally mix them up. There are 3 wires going to this one. Same thing with select fire switch itself, there are quite a few wires going to that. If you break a tab off or anything, just resolder it. Not too bad. Generally speaking though, you will want to solder it the exact same way it came out, and if you're not sure about that, you can use our reference diagrams. Other things that could be a cause for concern is you could adjust the magnet spacing, or the magnet switch, the reed switch spacing, by taking out the mag release pin and loosening or tightening that such that it lines up better with the follower in your magazine. However, I've never had to do that. If you want more than one dart left in the chamber, I suppose you could do that. I do know that by moving the switch up, you will then potentially require the magnet in the mag to move up further, or I guess vice versa. If you move the switch down, it'll detect it earlier, which can be helpful if you want to be extra safe, you're not dry firing. I've never done that. I've always kept mine in the bottommost position, and I just get one dart left in the chamber on semi-auto. I did notice though on full auto, because it is cycling so fast, usually the reed magnet switch, because of the follower, doesn't engage. It doesn't move up fast enough such that the reed switch cuts off the power before it cycles again. Moving that switch up though would only make that worse, I believe, and I think part of it has to do with how bouncy it can be with a vibrating, and the reliability of maybe your dart thickness as well, if you have new darts versus old darts. So I've never actually gotten the dry fire safe to work very reliably in full auto, but again, I never use full auto. But I'm sure you could adjust, again, the magnet position in your mag or in the blaster itself to dial in that for full auto. I personally don't think that's worth it. And I just run mine on the bottommost position here, and then conversely, the topmost position in my mag. Some things that can go wrong, again, is if you get dirt or muck in there, I would clean that out over time, like your ball here. This ball guide should move smoothly. If really there's any friction or too much friction at any point, you're increasing the resistance on the motor, resulting in the motor having a harder time. And as those things add up, let's say maybe your screws are loose, it's crooked, or your plunger, since this plastic is dinged up, you get dirt in there, grime, dust, you get dust in the ball cover here. So it has a lot to look out for. There's a lot of things that dust could get into and go wrong, but again, I ran mine in the desert here in Utah for many events back to back and haven't really had any problems other than get a bad jam, I don't stop cycling, blow out the fuse. If you have any questions at all, please reach out, and we can help you troubleshoot your blaster or help you dial things in more. Spring swap being the biggest one for that FPS. Again, reliability, consistency, accuracy, all of that's going to have to do more with your B-car, your barrel, and your darts, and your mag. The blaster itself is pretty simple when it comes to 2 switches and a motor that primes and deprimes. I mean, that's about it. Nothing that is very hard to replace though. I mean, you can get replacement boards, but I've never needed them. The only other thing I've had to replace is, I think, the Delrin plunger, because it is plastic. If you get something really jammed up in there, you know, you could potentially break the plastic. Or if you use too long of screws here or tighten them down too far, then it can nick up your plunger. But again, none of that is, I've only had that happen once, and it was mostly user error again. Yeah. Hopefully that helps. Again, please reach out if you have any questions. It is definitely worth it for that. If you're going high FPS, if you're going to any 300 FPS event, which there's a lot of. Now, I do know that some of those events don't allow you to have AEB 300 FPS because of whatever reason have you. But if you got a 300 FPS event, you know, the Storm is great. And you can dial it down to like 250. I don't think it's worth it to dial it down, because at 250 you could just run a Springer with a spring load that's not too hard to prime, or a flywheeler that's tuned well. You could dial this down to 250, and it would still maybe be viable, but because it is big and there is quite a bit of weight, I feel like it would excel. Like, there are other options that might do it better, but as far as high FPS, this is by far like the best high FPS. Like, it can hit high FPS no problem, and the accuracy is great. And the maintenance is not that bad. I would definitely not recommend it for someone who is intending to buy something and not ever having to maintain it. So if you do not want to have to worry about maintaining a blaster, cleaning it, or keeping a battery charged, or things coming loose over time, get a different hobby, honestly. But definitely don't go for the Storm as one of the first blasters you get. Although if you're okay with, hey, I feel like I'm pretty handy and I like to figure things out, with our help, the Storm is not a problem for you. I guess only other complaints would be the grip screws, gotta get a long guy in there. Troubleshooting that, not troubleshooting, but be aware that you need a long hex key to access those, or an adapter. I've used a Torx socket thing with a length and an extension in a screwdriver. That works just fine. Those are 2mm hex size. And then other than the aesthetics, cosmetics, you can of course mod that. Lubricate, again, regular maintenance, lubricate your O-rings, your pusher O-ring. If that's dry, it can sometimes come off. So just have spare O-rings on hand. It happens a lot with the Storm. Not a lot, but like it might happen more often with the Storm than others because you are cycling so fast. So that way it can get dry, and then it's rubbing so much that it can pop off, but that can happen on most any Springer that I'm aware of. I've heard that happen too. So hopefully this video is helpful. If not, let us know. If it is, let us know. And hopefully this helps you guys know more about the Sweetheart Storm. Most of the questions we get nowadays are, what's the difference between the Sweetheart Storm and the Black Raisins Blizzard or the Black Raisin Storm? The number one difference I know of is that this is by Sweetheart. Those derivatives are by third parties, not officially licensed or not doing things the way that Sweetheart does them. For those who do want to support the original creator, that is a big difference. The other difference is that I heard that the original Storms being produced by other companies were knockoffs, or they had different springs or something that they maxed out at 200 or 220, maybe 250 FPS. The Storm gets to 300 and above, no problem. The other differences, of course, are aesthetic. Of course, you do have like these back access windows for additional features, such as the shot counter, which just counts your cycles, which again, personally, I would not really ever use that. If I was gonna drop tons of money on like the end all be all, I want the best model possible, I would probably pay for those features. But as far as, hey, I'm kind of want to go with the cheapest option, that still works great. I think that this is the best option because it still hits high power. You don't get features you're not going to use. Even I don't really use a full auto very often. I do use a full auto though for the occasional suppressive burst, which does come in handy. But even the semi-auto, you get a decent rate of fire to be suppressive almost already, and it's already kind of outgunning all of the normal 300 FPS type people who run blasters that may be suboptimal 300 FPS or have a heavy prime. So it definitely holds its own against almost all high FPS. So to put it back together, you just drop this stock in through that wire, slide, make sure you're not pinching your wires. That's the only other thing I should mention also. We could put this in the beginning of the video, but this screw here for the stock goes right next to these little itty wires. I have happened on 2 or 3 occasions, I think. Again, that's 2 or 3 out of several dozen, that screw can break those wires if it's going into the wires. So just make sure that you're a little careful with this screw. I like to put the screw in, wobble it around, make sure it's not touching those wires, and then tighten it down. If you tighten that screw on top of those wires, that's another case for intermittent response, is you're losing a connection in your trigger wire. So obviously it's gonna be intermittent, but make sure it's on safe. And then if you're wondering about how to deprime it, I'll show you that. So you got 3 shots here. This is semi-auto, pretty fast. Those darts didn't come out, but don't use bad darts. But yeah, that was semi-auto. You're still getting, that's pretty good. And then deprime it, hold the trigger down on semi-auto, put it into safe. Super easy to use, easy to deprime. There you go.